All right, now the next formula is called the distance formula. Now it's a little tougher than the midpoint formula. Um, so we're gonna go through how to use it, and I'm gonna explain where it comes from, and it's a little more complicated, kind of why it works than the midpoint one. Okay, so to figure out what the distance formula is, or to see why it is what it is, we need to consider our line segment AB. First, we're going to again consider that they're x1 and y1 and x2 and y2, just like with midpoint. All right, but this time we're going to turn our segment into a right triangle. All right, because what it allows us to do when we have a right triangle is to just consider the rise and the run, kind of like we were doing for some of the midpoint problems. All right, so if you consider, okay, what's the length of just this side? Well, that's just the run, and this is just the rise. And you can easily calculate those. And here's how you do it. To find the rise and run, you may remember your slope formula from Algebra 1. It's y2 minus y1 over x2 minus x1. That's your slope formula that you learned in Algebra 1. Well, think about what this means. Our rise is y2 minus y1. So that's this. This is the rise. So to figure that out, I just do y2 minus y1. So we're going to use that in our distance formula, y2 minus y1. And then for the run, it's just x2 minus x1. So this is just rise over run. So this one here is just x2 minus x1. Now, like I said, we turned the rise and the run in the segment into a right triangle. And there should be a formula for right triangles that we've used a couple times during the year so far. It is the Pythagorean theorem, a squared plus b squared equals c squared. Okay, so really the distance formula comes from the Pythagorean theorem, because we can just take our rise and our run. All right, let's take the rise first, because the rise, x2 minus x1, that is one of our sides of our right triangle. The y2 minus y1 is our other side of our right triangle, our other leg. And we're trying to find the hypotenuse, that's the c. So these two are going to be my a and my b, and what I'm looking for will be my c. All right, so I'm going to just take my x2 minus x1 and plug it in for a. Don't forget to put the squared. Now we have to use the parentheses because we're squaring this whole thing. Okay, then we're going to do the y's for b, y2 minus y1 squared. That's our b. And then we're going to call this lowercase d. I'm going to change the c to a d just because it's the distance formula, so we usually say d for distance. All right, so my c is becoming my d. It's just the length of this segment. All right, now there's just one more step. Oh, I forgot, it's d squared. So it's just one more step because it was c squared. It's got to be d squared. All right, the last step we do when we do the Pythagorean theorem to solve it is to take the square root. And so when we do the distance formula, we just do the square root as a part of the formula. So this cancels out with the squared, and our entire formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And again, we say d equals for distance, d for distance. This is the distance formula. All right, this is kind of how you can see where it comes from. It comes from Pythagorean theorem, but really you just need to have this formula memorized and be able to use it.